So it is based on the theory that we build a model. Now, what we mean by building a model here, theory. So that's what we do in structural equation model. Right? So this model building in structural equation modeling is about the relationship among constructs in the theory. So that is our starting. When I say that to you, now you wonder what's going on here. When we talk about relationships, we are talking about in terms of statistical side, we are talking about the variations or the correlation, how one concept relates to the other. That's what we call the relationship. But we are now looking at the underlying side of it, right? Not the manifestation. In manifestations, we are looking at the observations, and then whether there's a relationship. Try to make meaning out of that. Right? So, for example, let's say a construct. Construct can be, let's say, love is a construct. Love can manifest in various ways in people. Right? I mean, you can. How do we measure love in real life? Right? We have to find a measurement, right, for that. Right? That's what we do in other statistical techniques. Right? Love is a construct. It's a concept. Love by itself is meaningless, really. When you think of it, I mean, what is love, right? And you can, until cows come home, you can argue, right? But when it comes to manifestation, we understand. Number of times the flowers are given, or number of times the kisses are given, right? We can measure. So because that's manifested, that's observations. So in variables, what we do is we say, okay, number of times kisses given is one variable of measuring love, or number of times gifts are given is measuring love. Right? But when it comes to structural equation modeling, we actually talk about love, that underlying meaning of that. We know that love manifests in different ways. So in structural equation modeling, based on the love, and then let's say the duration of the relationship, how long this relationship lasts, the time as a factor, you can take, okay, that's the dependent variable relationship, 2 years relationship, 3 years, or lifetime relationship, or whatever. And here's the love as a dependent variable, and time as a dependent variable. And then we can observe, how long the relationship lasts as the dependent variable, and love manifestation, number of gifts and all that stuff as independent variable. We can, through that observation, we can look at other statistical modeling. But when it comes to structural equation modeling, and if there's a theory that talks about love and so forth, right, and then we looking at time and love, the constructs, and their relationship. And this theory of love can say, for example, I'm now making up, that deeper the love, longer the relationship. We, based on the theory, now what we do is we now build a model. Now model means, in structural equation modeling, we say, okay, we know that more love means longer relationship. We build a model, theoretical model. How we test a structural equation model is that someone out there can go and collect data about love and the duration in various ways. Love can be measured in various ways, and time, their relationship can be measured, duration can be measured in various ways in relation to time. And then, so you get this set of data, and then you look at, here's the observational model, here's the theoretical model. Theoretical model relationship is such that this is the strength of the relationship. Well, what is the strength of the relationship in the observation? And then we try to match the two. If this data is actually talking about the theory, is related to the theory, then there will be a strong fit. What we mean by fit is that correlation, that relationship that we found in the observations and the relationship that we hypothesize using the concepts are very similar. That is the basis of structural equation model.